Let's understand the quotient rule. And the quotient rule is straightforward. It says that if you had two functions, let's say f and g, which are functions of x, by the way, and you wanted to differentiate f over g, then you can do this as follows. You can write g first, the function g that you have, multiply it by the derivative of the function x, subtract from this the function f times the derivative of the function g. And many people regard this as just an extension of the product rule, and I'm in the same category. And all of this is divided by g squared. So yeah, definitely there are a lot of computations, but sometimes this comes to our rescue. Let's look at some scenarios. So we need to find the first order derivative of the function a with respect to theta, wherein the function is defined as follows. Theta minus 1 times theta squared plus theta plus 1, all of this divided by theta cubed. And you might be tempted to say, okay, let's take this to be f and let's take this to be g, and let's just start by using the quotient rule. What I think in these polynomial types of questions is there might be some way to simplify the expression before even trying to differentiate. So what that means is that if you look at this numerator right here, if you multiply it out, or even if you know some identities or something, this will come out to be theta cubed minus 1. And that is being divided by theta cubed. So what that means is the function a of theta is actually 1 minus 1 over theta cubed, or 1 minus theta to the power of negative 3. And now it's really easy to differentiate this. dA over d theta is equal to, the derivative of 1 is just 0, it's a constant, and you just have this power thingy here, and so you have a negative sign, so we'll keep that, and the derivative of theta to the power of negative 3 is negative 3 times theta to the power of negative 3 minus 1, or you can cancel these negative signs and you will have theta 3 divided by theta to the power of 4. And this will be the derivative of this function. You can try the product rule here, the quotient rule, the product rule, whatever you want to do, and you will definitely get the same answer. Let's move forward. We need to find the first order derivative dz over dx if z of x is equal to cot of x. And if you know that cot is equal to cos of the variable divided by the sine of the variable, you can see that you cannot simplify this by the easy method, like in the likes of the easy method that we did right here. We need to apply the quotient rule here. That's perhaps the best strategy. So let's take this to be f, and let's take this to be g. And now, well, we can write the derivative dz over dx is equal to, you first write g, so sine of x, times df over dx, so the derivative of cos of x with respect to x, minus, you write f then, so cos of x, times the derivative of g, so that is the derivative of sine of x. All of this is being divided by g squared, so sine squared. And you know that the derivative of cos of x is negative sine x, so that means this entire thing is negative sine squared x. And we also know that the derivative of sine of x is cos of x, so cos of x times cos of x, that gives you cos squared x. There is a negative sign again, so that is negative cos squared x. All of this, by the way, is getting divided by sine squared of x. If you look a bit more closely, well, you can declare this to be the answer and you would be right. But if you look a bit more closely, what you can do is you can take the negative common, and now this is an identity. We know that for any number, the sum of the sine squared and the cos squared, that is always going to be equal to 1. So this gives you negative 1 divided by sine squared of x, or negative cos x squared of x. And that is the derivative of cot x. You might know this previous hand, but it's just a nice exercise of the quotient rule. Let's look at one more. we need to find the first order derivative again of sine x over x cubed minus 1. And now again, there is no simple way, at least one that I know of, to simplify this further. So let's just dive right into it. Let's just take it to be f. Let's just take it to be g. And then dy over dx, that is equal to, first you write at g, so x cubed minus 1, times the derivative of sine of x, minus, then you write f, so sine of x, times the derivative of g, so d over dx of x cubed minus 1, all of this being divided by g squared, so x cubed minus 1 squared. And this, we can just simplify it further. So the derivative of sine of x is equal to cos of x, so cos of x times x cubed minus 1, minus sine of x just comes straight again. This thing right here, the derivative of x cubed minus 1, we know that the derivative of negative 1, that's going to be 0. And the derivative of x cubed, well, that is going to be 3x squared. So let's just write 3x squared right here. All of this is being divided by x cubed minus 1 of this squared. And there you have it. If you want to write this in a better way, well, perhaps you can write this as 1 over x cubed minus 1 squared times, I don't know, x cubed cos x minus 3x squared sine x. Anyways, all of these forms are equivalent, and that is how you use the quotient rule. See you in the next videos.